Welcome everybody. So this is a kind of a unique collaboration we have today with our CLF Portland Hub and CLF Seattle Hub and CSI Portland. We're going to talk about how to implement low embodied carbon concrete specifications, and we've got some really great subject matter experts here today to share their experiences as well. We'll just do really some like housekeeping introductions. So for those in Seattle or who haven't joined from Portland before, my name is Katie and I help co-lead our Portland hub, and Galen and Lauren are on here really quick too if you want to give a quick hello. I think you're on here.
We are. I'm here.
Okay.
Happy to do this. Always happy to talk about specs and concrete, and excited to have this collaboration with. We have a lot more people than we typically do, so it's exciting to see so many folks here.
Agree. Wonderful to see everyone here. Feel free to continue with the intros to save time.
Okay. Claire, do you want to go ahead and...
Sure. I'm Claire McConnell with CLF Seattle. I know we have a few other CLF Seattle folks, Jess Harris and Yamini Bhatt, and possibly a few others. I know it's spring break week, so we're missing a few folks. And I will pass it right back to you to keep it moving.
Okay. And then Melody, really quick, if you want to just give a shout out for CSI.
Yeah. Thank you so much. I'm Melody Fontenot, the chapter president-elect for the CSI Portland chapter, and we really enjoy trying to support these efforts to improve specs for all of us. So we're happy to be involved today and excited for the conversation.
Yeah. And then we'll get introductions for our guests here in just a second, but the one or two little bits of housekeeping. We have registered this course for AIA HSW CEUs, and whoever can use those to self-report for other types of continuing education. So I'll put a link to this in the chat, but you can also there's a Google Sheet linked in here in a Miro that Melody just put a link to the board in the chat. So you can feel free to fill this out, or I'll send a link to the actual Google Sheet, Google Doc that you can put in your continuing education information in. And then we will also be sharing a link to a working group interest form for trying to gauge interest in forming a more regional spec working group for low embodied carbon specification. So it would cover, concrete, but also other potential subjects. And I think the intent of it would be that like workshops like this around wood or other types of materials, that spec working group could help organize, congregate resources, potentially new resources that might be missing, that kind of thing. So I think this is in here, as a link is in here as well. And we'll also share a link in the chat, and then we'll share out both of these things again after this call to gauge your interest. And then without further ado, I'm gonna stay off that for just a second, and then let all of our guests kind of go through a quick round of introduce yourself and what is like top of mind for you in low embodied carbon concrete currently. I don't know if you want to just start going, or maybe Chris, you go ahead and go first, and we'll just go through.
Okay, that sounds very alphabetical. Hey, everybody. I see a lot of familiar folks on here. I'm actually calling in from Houston, Texas today. It's like 73, 74 degrees. I know it's miserable and cold back on the West Coast, so I'll try to send some of that warm air back. I'm the founder and CEO of Bennett Builds. We're a comprehensive concrete consultancy. We represent owners, design teams, sometimes developers, and among other things, coming up with low carbon solutions for concrete, for flooring that are more within traditional schedules, traditional budgets, and things like that. And let's see, what was the second question? What would I like to see? I guess generally speaking, more collaboration, more early on collaboration. And I guess the general idea, if all members of the project team, if we can acknowledge that low carbon concrete is a new material, I think that'll go kind of pave the way for new ideas and new thoughts to not treat it, cure it, place it, finish it like we do with older materials that are less and less available.
Great, thank you. And then we'll have, let's see here, who's next on my faces list? How about Melissa? I see you next in my.
That sort of breaks our alphabetical protocol, but okay.
No, I was all ready to go.
Sorry.
You should go, Diane. If you're ready, you should just go. Just go, Diane.
We can stick to alphabetical. That's not how I
I think
intended
she
it
might
when
have
I
left
started.
our pre-meeting yesterday when we designed that. I'll go next. Diane Warner. I'm the executive director of the Northwest Cement Council. And the Cement Council provides education and design assistance for cement and concrete solutions and resilient construction in both Oregon and Washington. I've got 30 years of design experience in precast, concrete pavement, soil stabilization, and now low carbon concrete. And I am most excited, kind of building on what Chris said, excited about how much cement and concrete have changed more in the last 10 years than in the previous 100. And the shift both allows and requires designers and contractors to re-engage with the fundamental behavior of this wonderful material called concrete. We need to rethink how specific mixed designs respond during placement, how they perform long-term, trial batches, test slabs, mock-ups, wall panels. They're no longer optional exercises. They're essential qualification tools is kind of what we want to call them. And these controlled test pours allow the teams to evaluate the workability, finishing windows, which are really important with some of these new cements and SCMs, how it'll pump if you've got a pump on your project, strength development, shrinkage behaviors, and durability. We can evaluate all that before we commit that mix to our critical structural elements or anything on our project. And honestly, this process of testing, observing, and refining, that's the fun part. So we get to get back to that.
Thanks, Diane. Greg?
Well, I guess I'm next on the agenda. My name is Greg Halstead, and I am a senior director for local paving with the National Ready Mix Concrete Association. The NRMCA represents the concrete producers in North America. We currently represent a little over half of all the ready mix producers within the United States. So all those trucks you see going down the road, promise me you'll refer to them as concrete mixers, not cement trucks, because there's a huge difference. And I guess NRMCA is trying to encourage the use, obviously, of more ready-mix concrete in construction infrastructure, whether it's pavements, whether it's buildings, and we want to see it done properly, safely, and sustainably. And I think one of the things that comes to my mind, talking about concrete, and I can piggyback on what's already been said, is that it shouldn't be anything that's scary. It should be something that we think through at the beginning, as has already been mentioned, and then take the best approach to get to it. So understanding what your goal is, are you trying to reach a certain target of global warming potential? Are you trying to reduce a certain CO2 limit? Whatever it happens to be, we can work towards that. I think too often, a lot of us on this panel hear that, oh, we want something green. We want something low carbon. Well, we have to define what that is, work our way towards it. But again, it's exciting, as Diane mentioned. And I also want to say that it's not difficult. We can do it all together.
All right. If I remember my alphabet, Matt, you're next.
Yes, hi. My name is Matt Hoffman. I work with KPFF Consulting Engineers. I'm a structural engineer. Been with KPFF for, I don't know, I guess about 14 or 15 years now. I'm on our sustainable design committee, and we talk a lot about concrete and different ways, different strategies for having reductions below a particular baseline and specifying concrete, low carbon concrete on our projects. I agree and I second the importance of having early discussions and during project startup with not just the design team, but hopefully with contractors and ready mix producers as the project gets into construction, just so that everybody's on the same page about what the expectations are, what the possibilities are for low carbon concrete on a project. And also just kind of what I'm excited about moving forward is that also, like Diane mentioned, there's been so much change in concrete in the last 10 years or so. Once low carbon concrete has really become a big part of construction, especially here on the West Coast. There's been a lot of movement and a lot of change in what's possible, and I just look forward to that momentum continuing to build and us continuing to have more and more tools at our disposal for specifying low carbon concrete, including new SCMs, continued development of type 1L cement, maybe with higher percentage replacements and that kind of thing. So anyway, yeah, excited to talk to the group today.
All right, Melissa, you're up.
Okay, thanks. Yeah, hi, my name is Melissa Verwest. I work for Knife River, and I am our Sustainable Material Program Lead, which means I get to put my hands in all of the materials that our company deals with, aggregates, concrete, pre-stressed concrete, and asphalt. So I'm kind of looking at the sustainability side of all of these materials. I think it gives me a great perspective on how things are going, not just staying focused on one material. I'm involved in the product category rules for concrete and precast and probably aggregates coming up, so I'm involved in those committees. I work with our national organizations with NRMCA and PCI, developing benchmarks and baselines for these products. So pretty heavy involved in the numbers side of it, and that comes naturally because my background is a consulting engineer of over 15 years, where I worked on heavy industrial projects. So that was steel and concrete mostly for those projects. And one thing I learned there early on through consulting was that's the way to do a project. That early collaboration, get everyone to the table, whether it's the end users of what you're going to be doing, the people that are designing it, and then the suppliers. And I think that's what I'm really excited about most moving forward in the sector is the idea of sustainable materials across the board, no matter what material you're looking at. It's changing the way that we are looking at design. It's fundamentally changing how before we were all sort of in silos with the design bid build model, and now it's we have to work as a team and we have to understand what's out there. And so I see more and more suppliers like myself are at the ready to help in these conversations and really drive the goals that the clients and the end users are looking for.
Great, thank you. Okay, so we're gonna kind of just jump into the first section of this workshop, and also so the Miro link is in the chat again, so you can anybody in this call should be able to get in there. And I wanted to just make sure if you're seeing a Miro, you're seeing my screen. Are you seeing everybody? Okay. Great. I don't have the usual green highlighted box around what I'm sharing, so I wanted to make sure. So the first thing that we just want to talk about a little bit from all of our experts, but then also we're inviting everybody that's in this room to share your own experiences through writing down on the sticky notes some of the sticking points that you have had when you've tried to specify or design with build with whatever your perspective is for low embodied carbon concrete. So if anybody's new to Miro, these are the stickies, and you can double click into any of these and you can type on them, and then you can type on them. You can put them under the categories if you're having issues in procurement, specifications, or in design or other. You can delineate that yourself. So those of you in the room, you can do that while our guests are responding to a few questions that we have. So generally, I think we'll try and go through this quickly, but also enough time to get each of our guests to respond to these questions. And I think we probably understand there's probably common sticking points. So we'll try one of these and see how long it takes for all of you to respond, and we'll see how we need to maybe adjust for time, because we have another juicy section that we want to spend a lot of time on. So in general, I guess, and any of you, Diane, Melissa, Greg, Matt, Chris, just raise your hand maybe when one of you wants to respond. That way we talk kind of one at a time. But in general, where are you seeing this process get stuck? And what are the pain points from your perspective?
I guess I can start. So when we start having conversations about low carbon concrete on projects, generally where we get stuck is in discussions with contractors and ready mix producers. Even if we do have early conversations, it kind of depends on where the project is located to some extent. But we hear a lot of pushback on low carbon concrete, perceived increase in costs to provide low carbon concrete, finishability concerns where projects have exposed slabs. Obviously, when the contractor is trying to construct an area really quickly or strip forms quickly, there's concern about low early strengths with some of the high SCM mixes. So I'm not sure, not being directly in the concrete industry or placing concrete personally myself, I'm not sure if this is just kind of traditional, thought process on there's less cement, there's less, that's what you get. But that's kind of what we've run into quite a bit. We've had a lot of high hopes for some projects that turned out not to have quite the sustainability targets that we had hoped for originally because of some of the contractor concerns. So that's a big one for our project teams.
I would add an item to that too, and this is something that doesn't get talked about a lot for maybe some obvious reasons, but the capital expenditures, whether it's to meet, say, hyperscaler demands, but retailers, everybody's, unnecessarily so for low carbon concrete. Maybe it's workability, delayed day of strength, extended schedules for sure. But what's less talked about is something I've written about, something most of your real estate owners are dealing with, is millions of square feet of not structurally unsound concrete. Nothing's going to, fall over, but serviceability, being able to use those spaces. There are a lot of owners that have essentially some dark sites, and it's not like a little bit here and there. It's a lot. And it goes back to my first comment, and then I'll kind of give it back to the group, where there was a lot of early initiatives that were absolutely, well-meaning, well-intended, but teams forget that when you take a whole bunch of cement out and replace it with something that isn't, it's, for all intents and purposes, a different material. And so maybe I'm about to kill this horse in the desert, but that's the one thing I think above anything else I think would be a positive today is for everybody to realize with that idea of, this is not grandma and grandpa's concrete or whatever. It's a whole new thing. It's a new paradigm.
Yeah, Melissa.
Yeah, and I'm going to kind of add on from the perspective here of the supplier. When we get specifications, and I'm seeing this improve, but the specifications that we've seen in the past, when people were really trying, well-meaning folks trying to lower things, just blanketing, putting limits and restrictions on things. And so they would go off of, say, the NRMCA averages and say, yeah, we want a 20% reduction for this mix, this strength, that strength, everything. And when you look at these things, they have to be designed for what the application is. right? So if we want to get aggressive in goals and reductions, let's look at something that we're all a little more comfortable about, like sidewalks and curbs and places where we can be a little more aggressive and not have issues and not have concerns later with finishability and durability and strength and those things. Maybe we don't, run into columns and beams right away. Maybe as a structural engineer, that doesn't feel as well, right? So I think what it is a lot of those early specifications we saw, I know there was pushback because it was, well, we can't really do this because you're still asking us for, say, a certain air percentage. You're asking us for a certain exposure class. Those things require more cement. But then you're turning around and asking for a 20% reduction as well. They just don't match, right? So that's why I am just so heck bent on doing these early collaborations, because if we can talk about your overall project goals, then I think we can attain these things a little bit better. So I think there's a lot of work to be done in specification writing and how to really present those to contractors and to suppliers so that we can meet those goals. It can't be a blanket, we want to reduce everything. It's got to be application variable.
I think everybody. Diane, did you?
I'll just say one thing kind of on Matt's comment about how they've run into some issues and taken some forms off too early. And I'll give a plug to maturity meters. And when I said we've changed more in the 10 years than in the previous 100, the thing we haven't changed is cylinders. And there's a lot of talk about whether they are really giving us the data we need when we need it these days. So using some sort of maturity meter, knowing exactly what that product is reaching in strength at the time you need to know that. Because what we have found is that a lot of these concrete mixes with type 1L cement and more SCMs, they will reach higher strength than traditional mixes eventually, but it takes a little bit longer. And I wish I could say it takes this many days and this many hours for this element or that element, but we haven't defined it down to that level yet. And I don't know that we ever will. So you need to know what's happening with each of your elements on the site real time so that you don't run into those instances. 50, if you're going to stick with cylinders, which, that's the industry norm still, then 56-day strengths are better. And that really requires talking about your schedule. I'm jumping a little bit ahead to the difference between, site concrete and building concrete, but as Melissa said, sidewalks, streets, what you need to have for construction access. You need to know parts of that you actually need to have reach strength earlier, and other ones can take longer. And again, with the building element, same sort of thing. You have to know which ones you can wait a little bit longer for them to reach strength and which ones are imperative to get there sooner. And that all rolls into a project carbon budget, not a individual element carbon budget. So you can look at all these together, and your civil engineer and your structural engineer and your architect and your ready mix supplier can say, here's where you can save, here's where you shouldn't save. But overall get that carbon budget lower in the end for the entire project.
I see Greg's hand up, but I have to totally jump on that really quick and say we have had more success when we carbon budget for a project than we do when we are held to limits per element. So if you're a designer out there and you're trying to say, for this element, a floor, a beam, a column, a sidewalk, and you list that becomes very prescriptive and it's hard to match. But when we look, like Diane said, at a whole carbon budget, we've had much more success in lowering the overall GWP.
Really good points. Greg?
Yes, just to piggyback on all of that, anytime that you're making changes to a concrete mix, I mean, testing it, knowing what it is that you're working with is very, very important. I mean, if you changed your aggregate source or any other material in that, it's going to behave differently. And as we move towards these more low carbon type ones, we have to, as Melissa had mentioned earlier, design with the end in mind. What is it we're going to be using it for? And then become familiar with the product. I mean, as someone I think had said earlier, it might have been Diane, this basically isn't your grandfather's concrete anymore. it's a different one. So designing it for your use in a floor system or a column or a beam or a bridge or whatever, designed for that particular element. And then through carbon budgeting and things like that, you can get a lower carbon reduction for your entire project or for your entire structure, rather than just saying, I'm going to set a limit and go for it.
All right. I think, and so I think each of you touched like a little bit on some misconceptions already, whether it's cost or schedule, certain things like that. So unless anyone objects, I think we might move on to our next juicy section, which all of these, this is kind of the intro to our questions that we have on this next page, which does get at the crux of, like, you talk about GWP reduction targets, how, you know, the right process for specifying that and how we actually come up with those types of realistic goals and things like that. So I actually think that that's a good, that might be a good segue question to each of you. So I think what I'm going to do is I'm going to ask for this one, how do you set a regionally achievable GWP reduction target for your concrete mixes or for your concrete in total? And what I'm, just in the interest of time, I think we'll have some of you answer this question and not all of you. So I'm hoping that Matt and Melissa, you can respond to this at least to start out. And then if there are other some key things to keep in mind, we can invite our other experts to weigh in a little there.
Sure. Well, I kind of wanted to follow up on what Melissa had said, and I think Diane maybe too, about the project-wide kind of weighted average overall project budgeting approach, which I think I totally agree with. I think that is 100% the way to go for projects. It gives the contractors flexibility to put sustainable concrete down where they can wait longer for it to come up to strength, or they can utilize the option for a 56-day mix, higher SCMs buried in the ground, so you don't need to finish it to quite the same level. All those things are good ways to achieve higher reduction targets. And also considering what your elements are. So when we start thinking about what percentage reduction we're going to have on a project, we start thinking about, okay, well, how much of our concrete is ground supported is kind of the way we typically think of it. Those can usually have a slower strength gain and be okay, even especially foundations, slabs on grade. Even columns don't, on multi-story buildings, the column at the first level isn't going to be supporting the top level for quite a long time. So it can even have come up to strength a lot slower. Things that are not ground supported, especially like post-tensioned slabs and even spanning beams, cast in place spanning beams that would require shoring. Those oftentimes are not good elements to be targeting for reductions. And again, this is what an exercise we kind of go through internally when we're thinking about, okay, how much of our concrete is a good candidate for low carbon and how much of it is not. So then we kind of come up with something internally that we think makes sense based on some of our previous experience. And we would kind of bring that to the table for discussions with the contractor and hopefully the ready mix suppliers on board at that time too, because obviously they have the most valuable input of anybody at the table when it comes to what's actually achievable. And we try to arrive at a realistic reduction at that point. That's kind of how we approach it. Melissa, did you have anything you wanted to add to that?
I think echoing more than add, I'm going to sound like a broken record. Early collaboration. That is the number one key. Call your supplier, call me. Even if you don't use that supplier, all of us are trying to do this and reach these goals. So we all understand our regional capabilities, so they're going to be very similar. Going off of benchmarks, going off of averages, please don't go off of averages. Averages tell you the middle of what people can do. So you have half the people that will not achieve that. So averages are not a good launch point. What Matt talked about, it's truly application. If we're going into a project, say for a wastewater treatment plant, that's a heck of a lot different conversation on GWP than a sidewalk or a curb. And it has everything to do with that actual mix that we're using. So even scouring through EC3 tool and those things, they can be a bit helpful for your background information, but a 4,000 PSI concrete for a wastewater treatment plant is a lot different than a 4,000 concrete we'd use in a sidewalk. It's going to be different if we use it in the summer or in the winter. It's going to be different for any of the things we need to achieve whatever the purpose is for that concrete. So really, when you're trying to set these goals, you can start with those baseline knowledges. I think Matt's internal strategy is very good, looking at percentages of these concretes that you can have reductions in. But I would say before you put that percent reduction in your spec, call your supplier and see if it is regional available, regional viable. Call 3 suppliers. Make that effort, because you're going to get a lot of the same answers, and at least you'll get a range. I know for concrete, EPDs can be done on demand. And that means we can put in tests and see what we're looking at as far as strengths and some preliminary information you have on those attributes. We're never going to, my company will not publish an EPD unless it's for a project, because those go into a repository. But I can definitely work and see what those numbers are. So we can work with you early on looking at those targets, and then you can write your spec and you'll be able to achieve it.
Yeah, and you made a good point too about regionally. So when we write our spec, and I'll share it here in a second, but when we write our spec, we do have a table that shows the Northwest, the NRMCA's Northwest regional baselines for each strength of concrete. And that's really just to aid, there it is. That's just to aid the contractor and their calculations for comparison of the actual concrete used on the project to the concrete, if it happened to exactly match the benchmark from that's listed here. But like Melissa said, it depends on where your project is. So if you're in Portland, you hit pretty much right on to these numbers, is what we've found with our projects. And if you had no reductions at all and you just had blindly shipped concrete to the project, it would generally fall into this range of global warming potential in Portland. But if you go to Seattle, then your numbers are going to be a lot lower than this. Seattle just generally has greener, cleaner concrete. They have better aggregates than we do. They have type 1L cement across the board. I say we because I'm in Portland, the Portland market. But and even in Oregon, though, as soon as you move south of Portland or east of Portland, then you start to get higher than these numbers. And so just understanding where you are, what's achievable, reaching out, like Melissa said, to whatever ready mix suppliers are in your project area, and getting an understanding of what kind of reductions or even increases. I mean, the new ACI has recently released a code on specifying low carbon concrete, ACI 323, I think it is. I'm going off memory.
Yep, 323. That's correct.
Yep. So they have told engineers to not specify a reduction, but to specify a percentage of a particular baseline. So it could be higher than 1. So it could be 110% that you're specifying, but that's maybe the best that region can do, right? But it's not thinking of it as a reduction isn't fair to those who can't actually achieve a reduction, is essentially the approach there. So, yeah.
And I'll just add one thing. You all know Melissa now at Knife River. Greg and I, our members are cement companies and ready mix companies. And I promise you, just like Melissa said, they want to hear from you early. You are not a bother to reach out to them. If you want to know contact names of ready mix companies in your area where your project is, Greg and I can get you that very easily so that they can hear from you, because they really do want to have these conversations with you early. It's so important for their success and your success.
I have a rogue follow-up question to that, because I think this is probably an important, I don't know if it's as easy as a yes or no question, but I think one wish of some, at least architects maybe in this realm, is like that you could have, or I've heard this from other people too, is there a boilerplate low embodied carbon concrete specification. So what I'm kind of hearing is maybe for some of the language and submittal requirements and in a process, yes, but no two projects, especially if there are geographic variables or other types of variables, will likely be able to share the exact same reduction targets, and how that comes to fruition in a spec.
I think Greg could definitely answer this, but I know NRMCA has guidelines for specification writing.
We certainly do. We do have help and assistance out there for designing or for crafting, if you will, wordsmithing a specification, and certainly for low carbon.
And that's a good place to go, because we're suppliers are members of this organization. So you got both interests in mind when you look at those guide specs. So you have the understanding of what the designers and the end users are trying to achieve, and you have the background information of what the suppliers are able to do in language that can help them accelerate your goals.
And I guess one quick clarification on that is more about the actual the types of the uses of concrete on a particular project, and the mixed strengths and the potential GWP amount or target on those does seem like it would always kind of be on a case by case basis. The rest of the infrastructure for achieving those targets with specifications can be duplicated and copied, but that actual part of we can meet this goal, and kind of the concrete budget will probably have to vary because of all of the nuances.
Based on the types of concrete, the applications of concrete on the project, and the location of the project itself. And to some extent, the capabilities of the ready-mix supplier as well.
Yeah.
Not all have quite the QC lab that Knife River has.
Okay.
Yeah, and it's design attribute. It's another design attribute, right? So it's not something you can just put a blanket across. It is part of the design, is part of what you want to do, just like a compressive strength. You wouldn't say, let's just get 4,000 PSI, and that applies to every project. This has got to be the same kind of thing. So GWP and carbon reduction is a case-by-case basis to be most successful.
Okay.
I'm not going to disagree with the general premise of that, but there are certain exceptions. If I could add just real quick, and I know that Matt had earlier said that in some scenarios, geographically speaking, maybe you can't make much of an impact. Even when there are not significant amounts of SCMs available, or there's sophistication variances, maybe just experience variety with local suppliers, installers, I've always found that you can reduce global warming potential through very simple measures. Even if you're not, creating new world records. One of the keys that has been very successful for our work and for our clients is when you're developing those specs, number one, absolutely, particularly for your larger projects, absolutely include some of the readily available information that groups like NRMCA, PCA, folks like that will have. But also going through your specification and allowing for volumetric, allowing for less vertically integrated suppliers, allowing for testing and pilot procedures and things like that, even if you're going to phase them in. And kind of the punchline to that is, we have a lot of clients that want, for lack of a better term, cast in place slabs that are going to receive some sort of exposed concrete floor finish, whether it's for automated hard-wheeled traffic, schools, what have you. And we have been pretty good, regardless of the geography, of getting rid of about 50% cementitious just about anywhere, whether it's Florida, Texas, out here on the West Coast. And the GWP will change a little bit, obviously, depending on the constituent materials, but there are certain things that are achievable, maybe not quite like the boilerplate spec, but you can do, you can have some of that, I like to call it the sort of McDonaldization of, every hamburger tastes the same. You can get away with some of those for certain elements, certain concrete systems in your build.
And I saw that Nathan had a comment there. He does what I do in California. He worked on the ACI 323 committee, helped with that spec. So he has a good spec that he's offering to let folks take a look at as well and have at least be a starting place, because you will need to make it specific for your project, but having a good starting place is definitely something that's possible and can help get you started.
Yeah, and if anybody wants to just take a look at the Miro board too, there's a few sheets from our spec in there already that I don't know if it matches what Nathan's going to have in there, but I know that they're generally written by Shana Kelly, who is the one of the people on the ACI 323 committee. So, and a lot of the variables used in here are very similar to what you'll see in ACI 323. So I think it's fairly similar, although I don't know if it'll be the same as what Nathan has.
Okay. And then I wanted to just ask, so Chris, I think your comment about some strategies that you can do that are maybe a little bit less dependent on geography and those things. Would you consider those, like we have this question here about what are low carbon strategies that are cost neutral or cost saving? Would that be something that you would consider in that category, or are there other strategies that are equal in?
Yeah. And provide a little wayfinding if I'm not answering you exactly kind of how you're expecting it to. I think number one, anytime that you can open up competition and new ideas and have that exchange, allowing trial and error to happen, particularly in your project manuals, your specifications. And I did create kind of a little list of that. And I'm a big proponent of performance-based specifications, but with a caveat. You can have performance-based specifications that absolutely favor proprietary materials, or like I said earlier, vertically integrated distribution channels, transportation channels, things like that. Not that they're bad, I'm just saying it can favor it. And so within your documents, if you're going to specify more outcomes of maybe strength, durability, carbonation, chloride resistance, things like that. Also, let's see, what's another one here I had. This is a big one. There's, I don't know if we're allowed to, name drop or not. If nobody else cares, I don't care. There's some really cool, major global warming potential reductions because of methane in products like our carbon out of San Francisco. Blue Planet's got some really cool aggregates that certainly tilt the scales on that. And we do a lot of not just, the materiality changes, but I'm really big into increasing hydrolysis, because my clients don't want to wait 50 days, for global warming potential changes. They want to be ready to go, with the tilt panels going up that week. And so how do we then, in that kind of paradigm, make low carbon, but with, more kind of traditional schedules? And that would be, I think, like I said earlier, the pilot pours, extended monitoring, and I would hold back provisions as you're trying some of these new ideas out, rather than just outright exclusion and say, it doesn't meet historically what we've done for 20, 30, 40 years or whatever. I think you need to be a little flexible with that. And speaking as somebody that is, looking at the cost of how these things go, for our clients, just looking into that is going to pencil out much better for your clients, particularly in some areas of the country where there is not a lot of choice, not a lot of kind of traditional market competition for cement and aggregate. See, did I catch what you were looking? Do I need to take a breath? Let me know.
Yeah, I think no, I think that's helpful. And then I think in general, it's always good to know what might be strategies that aren't gonna that might face less resistance because of cost or other.
Talk with your volumetric and your mobile mixers. Portland's got a great volumetric community, and they might probably get some of the rocks and cement powder even from some of the same places. I like being able to add your cement and water all together, at one time on site rather than wait, 90 minutes or whatever anyway. But there's a whole bunch of choices. And again, this is nothing against ready mix has helped build this country. I love ready mix concrete, but there are other things that are good too. And I think having, a palette to choose from, where designers and owners can look more holistically at those available. It's good for your bottom line and what things cost. It's good for variety and options.
All right, great. Well, and Melissa, you have your hand raised, and I'm just going to do a quick time check. We have 8 minutes left. We did have one thing that we were going to kind of close out with, but I think with just like summarizing questions during the design and specification process. And I think what we'll do is some of you may have seen that section of the board. We can summarize what we have in there and send it out as a follow-up to this meeting, and so that we have more time to get through a little bit more of this section. This always happens. We should have this be like a 3-hour meeting next time. Melissa.
Yeah, I just wanted to comment quickly on kind of what Chris was starting to talk about, and he's getting into innovative products. And I'm all for that. I think that's really cool for concrete that we can do that. We have the ability to change that mix, and we have the ability to put those things in. But as designers and as folks that are specifying, what you have to remember are there are 3 major things that will be problematic or that we need to push something like that forward. One is, where is that proprietary new best thing I call the next magic beans? Where is it located? Because if it's located someplace that we have to ship it far, you could pretty much negate or go in the wrong direction of what the actual numbers show. So the GWP is a conglomeration of all of those things that come into it. It's just data, right? It's nothing we can change. So if the data is showing that we're traveling a far distance, that's not good for the data. Scalability. If you're talking about new products, and this is something you want to use in a very big project, that may not be possible. Whether that's a brand new cement that someone's developing, whether that's a new SCM, if the amount is not there to support that production, that's something we as a supplier can't get past. So that's a problem. The last thing is when we have to put them into our overall mix, that means we need information from them. This would be the information and the data they have associated with their product, which should come in the form of a primary data EPD. If we don't have primary data from that new startup, and a lot of them don't because they haven't been around for 12 months, if we don't have that data, we can't put it into our generator to feed our data set and give you a final EPD. The best guess, it's just a best guess, and we can't even do that. So unless we have those 3 things with scalability, location that makes sense, it's not a far delivery, and actual primary data from that innovative source, it's going to be hard for us to give you a number that we can stand behind with a total GWP.
I just have one quick comment. This is something Dave Walsh worked with us. He's an architect. He was a cell in construction. I think a lot of you know him through the Carbon Leadership Forum. And he talked a lot about this one particular example where you could, if you're looking at a floor plate and slabs in your project, and if you went from 16-foot span to a 32-foot span, you're going to increase your carbon by 84%. So you have doubled that span length, and you need 84% more carbon to get the thickness and the strength that you need on that. So he was a big advocate of looking at shorter spans where you'll save carbon and you can save money, obviously, if you're using less cement and less products there to get the strength that you need. So that was a concrete, for lack of a better term, example that he liked to give people of where you can save on carbon and money is span lengths.
And Melissa, you touched on scalability. So there's two various areas of scalability that I think would be good if we can touch on, even if it is just for these last 4 minutes. I think that there has been a lot of, and this might also be because we have more structural engineers in our local hub, at least in Portland, than we do civil engineers, but we talk a lot about building concrete and a lot less about site concrete. And so this would be, I think, to you, Diane and Greg, just your perspective on for talking about site concrete. If we are a civil engineer or we are somebody who is coordinating with a civil engineer, are the same strategies, like are these strategies that we're talking about for building concrete directly, or can you just use them for the site concrete, or are there special considerations to have in mind?
On a whole, as far as carbon reduction goes, or trying to set targets in a specification, they are for the most part very, very similar. Where I see differences is specifying a concrete, let's say you're going to be placing a pavement slab with a slip form paver. It has to meet certain requirements in order for it to be able to go through that paver. If you're going to try to open it within a certain amount of time, then maybe it's a little bit more forgiving on a pavement than it is a structural wall or something like that. So in those cases, the actual uses of the concrete might dictate a little bit of change in the language, but as far as how you're going to approach a carbon reduction item in a specification, I would assume they would be very, very similar.
I guess I would add that the exposure class of the concrete and the durability, the durability performance requirements of the concrete would on site would probably also affect the potential for reducing cement or lowering the GWP of the mix.
Yeah, I don't really have anything to add. I agree with both of those.
Okay. And probably reaching out to suppliers as well to talk about those options there. Yep. Okay. So in the last 2 minutes, I guess I'm curious if Claire and Melody, have you seen any, like, I think there were some questions in the chat that came up that maybe Melissa, you had responded to about East Coast EPD availability and other types of information. Did that get responded to? We could either focus on some of those questions or touch really quickly on single family residential in 1 minute.
I almost wondered, do we want to close with just, do our panelists each have kind of one quick final closing thought from what we've talked about today?
Yeah, we could do that.
Well, I'll go first because it's been my theme for this whole thing. Reach out to your supplier. The way that design is changing, you need to include all the players. And I don't just mean your concrete supplier. Obviously, that's what I promote. But I mean any material you're looking at. Reach out to your supplier and understand a little bit more of their material. So collaborate.
I guess I would say that at the bare minimum, even if you don't have a reduction targeted for your project, at the very minimum, ask that the project track the global warming potential of the concrete. And it just kind of makes it more commonplace and standard. Contractors get familiar with the process, collecting EPDs from ready mix producers. And it allows the engineers and the architects and design teams to kind of track what's the concrete that's being put into their projects, and just makes the industry overall more informed. So it's easy. Like Melissa said, most suppliers hit a button and they get an EPD from their mix. So.
As far as working with the material, I mean, understand that it's going to behave differently than a conventional or what the old time concrete mixes were. I mean, our old mixes had one type of cement, one fine aggregate, one coarse aggregate, and water, and we tested it at 28 days. Today, as Diane had mentioned earlier, it's a whole new era. We can have all kinds of blended aggregates, all kinds of different cements, supplementary cementitious materials, all of them going towards CO2 reduction in the product, but just be aware of the fact that it's going to behave probably a little bit differently than because you've changed the materials in the mix.
I'll just quickly say that everybody here should pat themselves on their back because the Northwest part of this country is very far ahead a lot of other parts of the country. So y'all are doing a great job with what you're doing. We track carbon savings just by the use of using type 1L cement in Oregon and Washington. And so from 2019 to the beginning of 2025, we saved over 500,000 tons of carbon just in Oregon and Washington by using type 1L cement. So that's a huge number. Be proud of that. And all of the SEMs and all of the cement reductions you can do are just adding on to that. So we're making a difference. Y'all are making a difference.
Chris, any closing thoughts?
Not for all concrete systems. Post-tension slab, you want to go nice and slow. But for a lot of other concrete elements, low carbon concrete, if designed correctly, if talking with your suppliers correctly, in my experience of removing cement from mixes over the last 10, 11, 12 years, as a budget kind of VE item, it's all low carbon concrete in those instances is the least expensive path for constructability. I don't think that's wildly understood. Widely, what's the word I'm looking for? Widely understood, maybe also wildly. But as we're moving forward, as we're having programs like this where we can talk about that, compare notes, I think that's going to become more obvious to everybody. And whether somebody's removing 5% global warming potential or 50%, I think generally what I'm very optimistic about is that's increasing. And I think we're going to start to see higher quality concrete outcomes as well.
Right, I lost track. Did we get everybody? Yeah.
I have
Okay.
to go through the alphabet.
Well, thank you very much for your time today and for your extra couple minutes. We'll send some follow-up to this event with some of the things that were shared. Really appreciate it. Fun. We need to have like 5 concrete spec workshops, I think, apparently, to cover everything.
We're there for you. You just let us know when you want to learn more.
Oh yeah, we could talk about concrete for hours.
Any questions?
All right. Thank you so much.
Thank you.
Thanks, everybody.
Bye.
Thank you.